This unit we've been focusing on what we call right triangle trig, and now we're going to look at another application. The past couple days we've focused on angles of depression and elevation. Today we're focusing on a topic called a vector. A vector is a quantity that has magnitude and direction. It has a starting point and a terminal point. And I guess this is a beginning point. The distance from the starting point to the end point is called the magnitude. And we're going to show you some examples here in just a second, just trying to get out some vocabulary. The direction corresponds to the direction the arrow is pointing, and a vector can be represented by a coordinate pair in the ordinate plane. This is called the component form. So, for example, I can give you the following vector 2, 3. So in that case, it starts at the origin, and we're literally going right 2 and up 3. There's the ending point, and this is my vector. And in a second, we'll talk about how do we find that length. Again, that length is called the magnitude. And this angle here is called the angle of direction. And there's a couple different ways we can express that angle. So let's take a look at this first example. This is our vector right here. The magnitude they've actually given us, it's that distance right there, which is 65. It hasn't been labeled, so we'll just be generic and say 65 units. The direction is this 50 degrees. And we're going to talk about compass direction here in just a second as well. Compass direction is based on north, south, east, and west. So we have north, south, east, and west. This particular angle here is 50 degrees south of east. So if you can imagine, they start heading this direction, which is east, then they decide to head in this direction. So here's kind of your first direction, and then here's that second direction. The initial point in this case is point O, and the terminal point in this case is called point L. And the component form is whatever this x distance is and this y distance. And so for now, again, we're just going to leave it as x comma y, and in a few minutes we'll talk about how do we find that. So first thing we're going to focus on is the direction, which again, as I said, is that compass direction. Let's take a look at this first example. Notice the arrow is starting here and then going in this direction. This is 35 degrees, so first of all they headed north and then they headed east. So we say that's 35 degrees east of north. Okay, let's take a look at the next example. Again, notice you're starting here and then you head this way. So that is 25 degrees south of east. Again, they headed this way and then they suddenly decided to head south. Let's look at this last one. This 20 degrees, they don't have an arrow, but really the first direction is directly north, south, east, or west. So that appears as though they were going this direction and then headed this way. So that would be 20 degrees west of south. Now, maybe instead you chose to see that you have this 70-degree angle. We could also do that. That would be 70 degrees south of west. Notice that initial side is on this side of the angle, and then you head in that direction. And either one, you end up with the same direction for the vector. The next piece we're going to talk about is how do we express this vector in component form. So we're actually going back up to this example right here. If we're expressing it in component form, we want the x and the y. So I'm just going to go ahead and pull out that triangle here. This is 50 degrees, this is x, this is y, and I have a magnitude of 65. Here's where the trig comes back into play. If I'm looking for this x value, notice that's adjacent over hypotenuse. So AH, so we have the cosine of 50 degrees equals x over 65. Now we can pick up our calculator. 65 cosine of 50. And we end up with 41.8. And then for y, we have opposite over hypotenuse, so that means we have sine of 50 degrees equals y over 65. Again, we're going to just multiply 65 times the sine of 50, and we end up with y is equal to 49.8. So last piece, if you go back up and look at the picture, we went right, which is positive, and then we went down. So that means our x value is positive at 41.8. Our y value is actually negative at negative 49.8. So this vector, we can either write it with its a magnitude of 65 with a direction of 50 degrees south of east, or we can write it in this component form. Here's my x, here's my y. Either way, we end up at that same terminal point, which is that point O. Alright, moving on to the back, same direction. They want us to describe the vector using component form. I'm going to draw in my right triangle here, and I'm going to just make it a little bit larger for us. So if you take a look, this is 371. This angle is 21. I can subtract from 90 to get this angle in here. Okay, and again, I want to find my x value and my y value. So same procedure as we did on the front. We have adjacent and hypotenuse, so that's cosine of 69 equals x over 371. Again, we're going to multiply 371 cosine of 69. At the same time, we have sine of 69 equals y over 371 because we have opposite over hypotenuse. Again, we get y is 371 sine of 69 degrees. I'm going to pause it and plug those into my calculator. Okay, so if you go back to your picture, take a look. We're going left and down, which means both of these values are going to be negative. So I get 140.0. Just notice when I round this to the nearest tenth, that rounded that up. And down here, I get negative 346.4 as well. Okay, let's take a look at the next example. In this case, we've been given component form, and we want to go back and find the magnitude and direction. So let's make a quick sketch of what this would look like. It says we're going negative 8, which would be here, and up 15. So a rough sketch would look like the following. We have 8 here, we have 15 here. So first of all, we're looking for the magnitude, which is the hypotenuse. Notice you have a right triangle, so we can back and use Pythagorean's theorem. I'm just going to label this to be h for the hypotenuse. Actually, let's label it m since that's the magnitude. So we have m squared is equal to 15 squared plus 8 squared. Plugging this in our calculator, we end up with 289. Taking the square root, we end up with 17. Next thing we're looking for is the direction. We're looking for this angle in here. I'm going to introduce a new variable that we often use when we're dealing with vectors, and that's the symbol theta. So we have opposite over adjacent. That's going to be tangent. So we have tangent of theta equals 15 over 8. This is when we go and do inverse tan of 15 divided by 8. And we end up with 62 degrees. So the way we can describe this vector, it has a magnitude of 17 units, and it has a direction of 62, and again encompassing what we did on the front side, this would be 62 degrees north of west. Let's go take a look at the next one. We have -7, -12, so again we're just doing a rough sketch. Here's our vector. This is 7, this is 12. I'm looking for the magnitude, so we have m squared equals 12 squared plus 7 squared. Plugging that in our calculator, we get 193, and 193 is not a perfect square, nor do I think anything goes into it. And it says round each to the nearest whole number, so we're actually going to take the square root of 193, and that is 14. So it has a magnitude of 14 units. Again, we need to go after that angle. I'm going to label this to be theta, opposite over adjacent. So tangent of theta equals 12 over 7. Again, this is that case when we're going to go and do inverse tan of 12 divided by 7. You need to see that on your calculator. And I end up with 60 degrees. In this case, it is 60 degrees south of west. Take a look. We were going here, and then we headed south. All right, let's go take a look at the two applications that we have sitting in front of us. It says Spain is 207 miles north and 428 east of Madrid. So 428 east, 207, so here is the vector we're talking about. This is 428 east. This is 207 north. They want us to describe the direction, and they want us to find how far. So again, how far would be that magnitude. So same deal, we're going to go and use Pythagorean's theorem. Let's go plug that in. 207 squared plus 428 squared. 226,033. We're going to go and take the square root. We end up with 475 kilometers. Second thing, we're looking for the angle. So again, we're looking for this angle in here. Opposite over adjacent. Tangent of theta equals 207 over 428. Again, we're going to go and do inverse tan. 207 over 428. Plugging that in our calculator. We end up with an angle of 26 degrees. Okay. Last one, it says it flies 73 feet in a straight line to a point that's 41 degrees west of north. So that means we're heading north, and then we're heading west. Here's 41 degrees. My magnitude is 73. They want us to find it, what it would be in component form. I drop this in. This is my x, and this is my y. One thing I want to point out, I'm actually going to go and find this angle. 90 minus that 41 gives me 49 degrees. I'm going to pause it, give you a minute to set it up, and then I'll come back on. Okay, so this angle in here was 49. Again, we have adjacent over hypotenuse using cosine. Then I have opposite over hypotenuse using sine. Last little piece, so I plug those into my calculator. I'm going left and up. So again, if I'm going left, it's that -47.9, and then I have the y to be 55.9.